Yeah, good evening. My name is Soya. So I want to talk about the innovative solution for sustainable agriculture. So the use of Arduino, that is the driving animal control system for safeguarding germination of soya beans. So the proposed project seeks funding to develop an innovative solution to address the perceived challenge of animal interference during the germination phase of the soya beans. So traditional method of the crop or of the crop protection was not so that effective anymore because those technology we do use back then, animals are adapted to it. They don't see it as a big deal anymore. They are not scared of it. For example, the use of crop. But this project aims to utilize a genome, a microcontroller program to the dynamic sound, it's a dynamic sound effect. So the use of the dynamic sound effect is that, so as we all know that human being are, we have we have the characteristics of adaptation that makes us a human being. So if you use maybe if you program the Arduino in a sense in a way that is going uh, to respond to sensor, to respond to any sound, maybe sound or movement of animal. So animals will they will adapt to it. So and that thing will not be effective again anymore. So as for this, that's the reason why the Arduino will be programmed in such a way that it will be dynamic. It will not be static or maybe it will be responding to maybe a signal. It will be dynamic in such a way that if the animal maybe is going to be dynamic like 15 minutes, 30 minutes, or it will be very 30, 15, 10, and the like. It should be very so the sound will be dynamic. And also the sound at which the Arduino will be producing each time will be different from the other. Take for instance, at the first minute, so maybe the sound is going to sound like that of maybe a cat, just just going to scare those animal rodents and the likes. That's going to scare them away. So like the second time of the signal is going to be in form of maybe in form of the dog, the barking dog. So on the right, the other maybe in form of the roaring animal or the roaring animal. So in last, and this project aims to cover a lot, with the use of an animal because with this project it's going to involve the use of an a microcontroller as well as the motion detector. So the motion detector will be in form of maybe in form of a big animal, young animal. So it's going to sensor it, maybe take for instance a type of monkey. So we have a monkey and we know that monkey dog is a predictor of monkey. So anytime the sensor sense every impact on the land on the side of the farm. So it's going to it's going to trigger the what is it called? It's going to trigger the dog sound, that is the barking sound of the dog. And we all know that the dog is a predator to all those monkeys and the likes. So it's going to bark. So we are going to use a motion detector and also environmental sense. So with this environment, I think I've explained this earlier. So and also we're going to use of the actuator that is sound producing effect that's going to be producing the sound serially and we change the sound as the time move from one time to another. So and as I've said earlier that you're going to use it's going to be in form of programming language. We are going to program the Arduino. So and with this we're going to lead the software that we are going to program this will be a program that will program the sound. It's going to be a programming logic. A programming logic that it will trigger the sound range of sound, different ranges of sound. So expect any I think I've explained it. It will be detecting the motion of different animal, maybe maybe a higher animal now, maybe a higher animal is going to trigger a sound that we chase away such animal. Take for instance now, maybe I think I'll give an example on that. Maybe now the sensor sends the movement of the rodent, or the movement of the rodent. So the sensor is going to trigger the sound of the cat. So it won't trigger the sound of maybe a dog or a lion, a wild lion. So that's, I think that would be better when we use a software that's based in a programming language that's going to put in a logical way. So I think I'll break this. Most of the content are in my write-up that I've written. So, and advantages of the solution. The solution have brought a lot of advantages, brought a lot of advantages. For example, the target detects specific animal during the germination. That is, during that germination, what we know is that most birds they usually they are attracted to the dicotyledon of the soya beans. They do feed on it because of the content, water content in the soil in the dicotyledon, and also another thing as well. The soya beans is going to be easy for them. The dicotyledon seed of the soya beans is going to be easy for them to digest in their gizzard. So I think that's the reason why maybe that's the reason why they love taking the particular germination stage. Because at times they do take the ungerminated one as well. You have to dig holes. You will dig holes. You will dig out the planted seeds. You will dig them out, chop them, and that's going to be that will reduce the agricultural output. So and this as well goes on, they are going to feed on the seed before germinating. After germinating, they are going to feed on the dicotyledon as well. That will reduce the production rate drastically. It will reduce the agricultural output drastically. So and the inputs, take for instance, maybe we planted 100 acres of soya beans. At the end of the day, if proper care was not given to the other animals and rodents and life, so we won't we won't harvest. We will not harvest our expected calculation of 100 acres of soya beans. We will not attain that just because of what we are negligence or under the maintenance of what of the farmland. So normal uh, with this project it's going to last. I think for a standard farm, it's going to last maybe a year or more, 2 years. It's going to last. The project is going to take on like 2 years or more if care is not taken. Or it depends on how large the farm is. So, but for a small, maybe 10 acres, 5 acres of land, 5 acres of soybeans, so I think that will not take a lot of time. Unlike those that involve a period of maybe 100 acres of land. So, I think the design for such is going to last from 1 to 3 months. That's going to last from 1 to 3 months. Total is regulated. It's going to be each year. The explanation and the is going to be year. The total duration of the year time. I see. Again, motion to again work. So the duration and calculator is going to be here. So the first 3 months is going to be on the development of the software. While the the second 2 months that's going to be on the prototype testing. We're going to use what we programmed. We're going to test the prototypes as well. So the next 3 months that's going to be what fit track. So we are now going to all what we all our programming, our prototype. So we are not going to take it to the farmland for proper investigation and proper trial. So the next a month, so that's going to we are now going to collect the data analysis of before we started using the solution to agricultural locate up when using Arduino. So we are going to collect the data output, our data output back then, and our present output now when we started using the this solution and provide. So we're going to collect the data data analysis. We're going to do the data analysis of our farm output. That's going to concerning our budget. So our budget is going to very good. It depends on the start of the farm. So for your normal standard family, so we are going to need a budget of I think $80,000. That would be maybe the hardware development. That's going to take
I don't send
$20,000,
2K now.
and also the programming of software
I
development. That's
sent
going to
2K
take
for that day and the other day.
for programming and software development. That will take at least $15,000.
Yes.
So while if we try and data analysis and data collection, I think this is going to be take this will take much of our explanation because we're going to do and try and error. So that maybe there's an error in our programming, and so
Yes.
sure there might be a wastage. Yeah, there must be a wastage. But that's going to they're going to manipulate things,
I think that
getting it done. And so I think that will take at least $25,000.
Wait, which one are you talking
out of
about?
the $80,000 budget.
You're talking about
$80,000 budget.
you're talking
So,
about
and
yesterday's
also
number.
the analysis and what analysis and reporting.
Oh yeah,
So
the point.
that will take
Sure.
anything that comes to do with analysis is going to be taxing work. So we are not going to that will take at least $10,000 out of the expenditure, and also outreaching and education. So we are going to confirm some expenditure out of a lot of things. The expenditure is going to be in form of the way that we are going to carry out some approximately of what our farm output is and what we got before we started using the solution and what it started getting after. So I think that's going to be that will take some amount as well. That will at least like $5,000 as well. So and also our contingency, so that will take at least $5,000 as well. So I think with the summation of everything, that's going to be $80,000 for a normal standard farmer. So for a normal standard, at least 300 acres above, the range of 500 acres of land. So I think with this solution, there's going to be a very bogus in our output if we try to apply a solution on our farmland. So I think that will be all for today. So